Hi, everyone. So we are going to get started. This is called, let me get my text. This is called 8.3 Part 3 Notes. Okay. Most importantly, we're going to start graphing. Okay. So everything we're going to do today, finding the axis of symmetry, your vertex, and the y-intercept, you know how to do. That was in our previous video. Now we're going to put that all together and graph it. Okay, so we've just got a couple examples. So let's go ahead and get started. So let's find our axis of symmetry. Okay, now our axis of symmetry, which I'm going to call number 1, that is using our formula x equals negative b over 2a. All right, you should have this memorized. You did this a lot in the notes and a lot in our homework, our last assignment. Okay, so this is number 1. So I'm going to go ahead and identify what my A, B, and C are. That's always important. A is 2, B is 4, C is 3. That way you don't make silly mistakes. If you watched my last video, you saw I did a silly mistake. I accidentally calculated something in my head and wrote that down as opposed to the right value. Happens all the time, so be careful. So x equals, let me see, negative 4. So I'm simply just plugging everything in over 2 times, now a is 2. Okay, so plugging everything in. So this will give me negative 4 over 4, which is a negative 1. Ooh, that's nice. We can work with that number. So your axis of symmetry is at negative 1. Okay. So let's hang on to that number. X equals negative 1. Now let's go ahead and find our vertex. I'm going to change colors. My vertex I'm going to call number 2. So your vertex is always going to be a coordinate pair. The x value is the x value of your line of symmetry. So it's going to be negative 1 comma something. To find the y value, remember you just plug it back in. So I'm going to say y equals 2 times negative 1 squared plus 4 times negative 1 plus 3. Okay, so that gives me 2 times 1. And then 4 times negative 1, that's a minus 4. And then plus 3. So that gives me 2 minus 4 plus 3, which would then give me 2 minus 4 is a negative 2 plus 3. All that gives me a 1. So my vertex is at negative 1 comma 1. Okay, I'm going to look at my A value. It's positive, so I know that my graph is facing up. Okay. Now my y-intercept, remember that's always your C value. So my y-intercept is going to be, and I'll actually change colors here, we'll make it orange. So my y-intercept is going to be 0, 3. Okay, so let's go ahead and put this all together. I'm going to scroll down. Let me move where my y-intercept information is, so it's not right on the graph. Okay, so our y-intercept is at 0, 3. All right, let's put this all together. So the very first thing you want to do is you want to draw your line of symmetry. Okay, so the line of symmetry is always going to be a dotted line, and it's always going to be vertical. This is a big deal. So it's always a vertical dotted line. So it's at x equals negative 1. So that's going to be right here. And you just make a vertical line going up and make sure it's dotted. I know it's a little hard to see because I'm actually on the line, but it is a dotted line. Okay, you make it dotted so you don't actually think it's part of the graph. We see that as our line of symmetry. Now your vertex is at negative 1, 1. So your vertex should always be on the line of symmetry. Okay, so I'm going to make a big dot here. That's my vertex, negative 1, 1. And then my y-intercept is at 0, 3. Okay, so what we know about parabolas, guys, is that they are perfectly symmetrical. So this is my line of symmetry. So my parabola is going to be facing up, and it's going to be U-shaped. So it's going to go through the vertex and hit your y-intercept. So from your line of symmetry to 3, it's 1 spot away. So I should expect another point over here. I should expect a point at negative 2, 3. And I'll prove it to you. We don't have to actually do the work because you know it's going to be perfectly symmetrical, but I can prove it to you by plugging in negative 2. So I'm going to go ahead and plug in negative 2 here to prove that I do in fact get 3. So that's y equals 2 times negative 2 squared plus 4 times negative 2 plus 3. Okay, so then that will give me negative 2 squared is 4. 4 times 2 is 8. Okay, and then 4 times negative 2 here is a negative 8. And then a plus 3. So 8 minus 8 goes away. That gives me just a 3. So when I plug in negative 2, I get 3. Again, you don't have to do this work up here. I was just simply proving to you that you get this perfect symmetrical parabola. Okay, that's it. That's all you have to do to graph. Please make it easy. Please notice I didn't even make an XY table. If you simply follow the instructions, find the axis of symmetry, the vertex, and the y-intercept, your parabola builds itself. All right, so we're going to go to the next example. If you feel comfortable, why don't you try this one on your own by pausing it and then pushing play when you're ready. If you're not quite ready yet, well, why don't you do this one with me, and then we'll have a third example you can practice on your own, and you'll have these to do in your homework. This is exactly what your homework looks like. In fact, if you look at the instructions, then drag points to graph the function. I took this from one of your homework problems because it's digital. So this was a digital graph before. Okay, let's see. So we're going to find 3 things: your vertex, your axis of symmetry, vertex, and y-intercept. Okay, so let's go ahead and find your axis of symmetry, which is x equals negative b over 2a. Okay, so then I'm going to label my a, b, and c. A is 1, b is 2, c is 4. So that will give me negative 2 over 2 times 1. Okay. So then that'll give me just a negative 2 over 2, which is just negative 1. Okay, same line of symmetry. We'll take that. Now let's go ahead and find our vertex. And I change colors. Let's go ahead and use pink. You guys know I'm a sucker for pink. So my vertex is going to be at negative 1 comma something. I'm actually going to do that. Call this my vertex here. All right. So we're going to plug negative 1 in. So y equals negative 1 squared plus 2 times negative 1 plus 4. So that gives me 1 minus 2 plus 4. Okay, so then that'll give me a negative 1 plus 4, which leaves me with a positive 3. So my vertex is at negative 1 comma 3. Okay, so I'm going to go ahead and box that. That's important. I'm going to make sure I pay attention to my line of symmetry, which is at negative 1. Friendly reminder, guys, your line of symmetry should be the x value of your vertex. Those should absolutely match. Okay, and then let's go ahead and get a third color to find your y-intercept. Your y-intercept is your c value, so it's going to be 0, 4. All right, let's put this all together and see what the graph looks like. So my line of symmetry is what you always graph first, and that's at negative 1. And it's going to be a vertical line. So here we are at negative 1. I'm making a vertical dotted line. If you're doing this by hand, you can highlight it. A lot of people take a highlighter because if you can see, my vertical dotted line gets lost on the graph because the graph is actually there. You know, the line's overlapping. Okay, so now my vertex is at -1, 3. So that would be right here. And then my y-intercept is at 0, 4. Okay, so my parabola, remember the vertex is where it all starts. It's going to start at the vertex and face up. It should face up. My a value is 1. Now to get a point on the other side, this is your y-intercept is 0, 4, and it's 1 away from your line of symmetry. So go 1 away again. You should have a point at -2, 4. And then you got your perfect drawn parabola. Now, if I plug -2 in, I will get 4. I'm not going to do that because we did it on the last time, and there's no need to. You can use your line of symmetry to build your third point. Okay, so I'm going to clear this, and let's go ahead and get to our last example. And why don't you pause it and do this one on your own, and then push play when you're ready. I know there aren't instructions here, but this one is asking for you to graph it, and it's, you know, they gave you the equation in standard form, which is what you always want. Remember, that's descending order. All right, well, let's get started. Let's go ahead and first find our line of symmetry. I'm going to use blue. So x equals -b over 2a. So then that will give me -8 over 2 times 2. So that'll give me -8 over 4, which gives me a -2. Okay, so my line of symmetry is at x equals -2. All right, now let's go ahead and find our vertex. So my vertex is going to be at -2, whatever I find for the y value. So that'll be y equals 2 times -2 squared plus 8 times -2 plus 5. All right, so then this will give me 2 times 4 minus 16 plus 5. Okay, so this gives me 8 minus 16 plus 5. So then 8 minus 16 is a -8 plus 5. -8 plus 5 is a -3. Okay, so my vertex is at -2, -3. And then orange, I'm changing color to orange to get my y-intercept. Your y-intercept is always your c value. So that will be at 0, 5. All right, so we're going to put this all together and graph it. So in blue will be my line of symmetry, which is a vertical line, always dotted, and this at x equals -2 here. Okay, and then my vertex is at -2, -3, -2, -3, so that's here. I should expect my graph to be facing up because my a value is 1. And you know, this is a good self-check. My y-intercept is at 0, 5. So that is forcing my graph to face up. If my y-intercept ended up being below my vertex, I'd be worried because then it would be facing down, and there's no way this graph's facing down. So there are some good self-checks here. Okay, so remember, it always starts at the vertex, and you go up and make a U shape to hit your points. Now to get a point on the other side, a parabola is perfectly symmetrical. So start at your y-intercept. It's 1, 2 away from your line of symmetry. So go another 2 away, and you have another point. And go ahead and complete your U shape. And then you have your perfect parabola. If you were to plug in -4 into this equation, you would get 5. And you know, there's no need to because, you know, a parabola is perfectly symmetrical. So this is our perfect graph. Okay, let's keep moving. We're going to go ahead and skip this example. I think you guys have seen enough. And we're going to get to our last two parts. This is talking about, I know this is a very wordy question. What's happening here, okay, so let's read it. The trajectory of the water from fountain A is represented by this function, this equation, in standard form, while the trajectory of the water from fountain B is represented by a table of values. Compare the vertex of each function. Okay, so I'm going to underline that because that's what we're going to be looking at. Compare the vertex of each function. Which trajectory reaches a greater height in feet? Okay, guys, so here's the thing. What's happening, and let's talk about some vocab here. I want to talk about the words maximum and minimum. Okay? The word maximum, and then I'm going to put minimum here. This has to do with the vertices, the vertex. So a maximum is when your graph is facing down, because your vertex is the highest point of the graph. Okay? So when you have a maximum, it's a graph facing down. Vertex is highest point. When you have a minimum, your graph is facing up. Okay? And your vertex is your lowest point. Ooh, I just see I didn't have graph is facing down. I didn't add the word down here. Graph facing down, vertex highest point. When it's a minimum, graph is facing up and vertex is lowest point, thus calling it a minimum. All right, so what is going on here in this word problem, they want me to find the vertices in both parabolas and compare them, okay? So in both graphs, well, this is a negative, so I should be expecting it to be facing down. Okay, so fountain A is going to be facing down, and fountain B, I can find my vertex by looking at the table of values. Your vertex is always going to be the point that's not repeating in the y values. So see how your 8s are repeating, your 5s are repeating, the 10 is not. So I can identify this as my vertex. So since 10 is bigger than 8 and 5, I can see that fountain B is also facing down. So they want me to compare vertices. More specifically, they want me to compare y values of vertices. Compare y values of vertices. So whenever you hear them talking about maximum or minimum, you need to look at the y values of the vertices. So let's go ahead and find my vertex in fountain A, and then we'll compare the vertices in A and B. All right, so let's do some math here. To find the x value, you have to go with your line of symmetry. So x is negative b over 2a. So that will be negative 2 over 2 times negative 1, because your a is negative 1. So then this would be negative 2 over negative 2, so that will be 1. So my vertex is going to be at 1 comma whatever the y value is. To get the y value, remember you just plug it in. So I will go y equals, yes, I see it says f of x up here, but you guys already know that's the same thing as saying y. So y equals negative 1 squared plus 2 times 1. I'm not going to write a 1 plus 8. Okay, so 1 squared is 1, but it's negative. So negative 1 plus 2 plus 8. All right, so that'll get negative 1 plus 2 is a 1. And then plus 8, so that gives me 9. So my vertex for fountain A is at 1 comma 9. My vertex for fountain B is at negative 4 comma 10. So they want to know, compare the vertex of each function, which trajectory reaches a greater height. So this means which has a bigger y value. Bigger y value. Bigger vertex, bigger y value in vertex. Okay, so if I'm looking at it, fountain A has a 9, fountain B has a 10. So my answer, all this work, and my answer is fountain B. Put it in blue. Woohoo! Fountain B has a greater height and trajectory. All right. So what I would say is this just has a ton of vocab. Please don't freak out by that. When you hear maximum or minimum, look at the vertices. So let's get to our very last example of these notes, and then you are done. All right, compare the function, and here's a function, to this function g shown here. What are the maximum values? Which function has the greater maximum value? Okay, so first of all, when they say maximum values, that means y value of vertex. Which function has the greater maximum value? So we just need to look at which one has the greater y value of vertex. Okay. Obviously, if it's graphed for you, it's so easy to find your vertex. So let's go ahead and find my vertex here. It's here, which is at 3, 0. Okay, so that's easy. It's nice when it's graphed for you or given to you on a table. If it's given to you in an equation, like here, we have some work to do. And yes, it's decimals, but we'll be able to do it. So I'm going to go ahead and do that in pink. Okay, so I'm going to find the x value of the vertex because that's how I find the y. So x is negative b over 2a. All right, well, we had to do decimals at some point, so let's just go ahead and embrace it together. So this would be negative, and then b is negative 0.6 all over 2 times negative 0.3. Okay, so I'm going to clean up my negatives here because there's a lot. So 2 negatives make a positive. And then this would become 0.6 over negative 0.6. Ooh, this makes me happy because that turns into a negative 1. Phew. I was a little afraid because it was looking ugly. So x is negative 1. Okay, now to find the y value, you guys already know, you just plug it back in. All right, let's go ahead and plug negative 1 into this mess. Let's see what we get to get our vertex. So y equals negative. Okay, so we can speed things up here, guys. Well, no, I'm going to go ahead and plug it in, and then I'll simplify it a little quicker. So I'm going to plug in negative 1. I was afraid to skip a step because you guys know I'm the queen of little mistakes, and I hate it, and I really don't want to make a mistake, especially on video. Okay, so negative 1 squared is 1. 1 times negative 0.3 is just negative 0.3. We can work with that. Okay. And then negative 0.6 times negative 1, that's going to turn into positive 0.6. So plus 0.6. And then minus 0.2. Okay, so negative 0.3 and 0.6 turns into positive 0.3 minus 0.2, which turns into 0.1. All right. So the y value of my vertex is 0.1. Okay. First of all, to answer the first part of the question, what are the maximum values? Well, there are 2 maximum values. Your maximum values are 0.1 and 0. You know what? I'm going to type this. So my maximum values are 0.1 and 0. Which function has the greater maximum value? So you're just comparing which one's bigger, 0.1 or 0? Well, obviously 0.1 is bigger, so the first function has the bigger one. So I would say f of x. So which function has the greater maximum value? F of x has the greater maximum. Okay, guys, that concludes today's lesson. Thank you so much. I miss you all in person, and I'm here anytime. Just shoot me emails and I'm happy to respond. Have fun doing your homework and have a great day. Thank you so much.